Hey everybody, it is Cameron here at Letta, and we recently introduced something called the memory tool. The memory tool is Anthropic's approach to something similar to what Letta agents do, right? It can modify, create, delete, rename various memories. In Claude's case, this is basically text on your computer. Now, that's our entire focus, right? A lot of the reason that Letta exists is agentic memory, or making it so that your agents can remember everything. So one of our researchers saw Anthropic's Sonnet 4.5 release and their announcement of the memory tool, and he hacked a memory tool into Letta in a few hours, and it changes the game. It completely changes how Letta agents function, because prior to the memory tool implementation, there was no way for agents to modify their own memory architecture, meaning which blocks they had available. Typically, what you'd have to do would be manually edit the block. So a common flow for me when I was designing the memory architecture of an agent would be, I would work with it on a problem, I would talk to it, and I would realize that it wasn't quite tracking the information that I needed, so it kept missing things. I would ask it to describe a new block or something, and then I would go and manually add it to the agent. Now, if you give the agent the memory tool, it can just add that block itself. And what this means is that your agent is capable of fundamentally altering its own architecture at its own will. I personally am extraordinarily excited to see what people get up to with this tool. And I'm going to show you a little bit of how the memory tool works and what it means for the agent to modify its own architecture. Take a look at this. I'm just going to play around and I'm going to show you how powerful this tool can be. Look at it, think about all the things that you could do with it, just give it a shot. I highly recommend that you do this with Anthropic's Sonnet 4.5 model. They post-trained on this tool, so when you're working in Letta using Sonnet 4.5 with the memory tool, your agent will just perform much better. So I highly recommend it. So I've signed in here to the Agent Development Environment in Letta Cloud. I'm going to go ahead and create a brand new agent. And I'm going to start completely from scratch here. Let's pick a name. Then I'm going to select 4.5. Next, we have to do the most important thing, which is give your agent the memory tool. We don't attach it by default yet because it's new and we haven't quite figured out how having that tool impacts agent behavior. A lot of Letta is calibrated towards our default tools, which is memory insert, memory replace, and memory rethink. But let's go experiment with it. I'm going to click the Tool tab here, go to Tool Manager, Base Tools, and you'll see the memory tool here, attach tool to agent. Now we can see that it has it here. I'm actually going to remove memory insert and memory replace. And as we can see here, we don't have any blocks. So let's introduce ourselves. So I told it my name is Cameron, that I'm making a YouTube video. I'm asking it to take responsibility for self-improvement. And I asked it to create some memory blocks. So you see here, it wants to create a block about me, a block for self-improvement goals, for insights and reflections. Okay, we see user Cameron over here has appeared. Now it's adding a self-improvement log that seems to contain information about tracking its own growth. We now have an insights and reflections block. All right, so what would you like me to focus on first? So let's ask if, what it would need to self-improve. Like, how can I help it self-improve? So I'm asking maybe if it wants access to some form of outside information. So it has added a minor note in here, which is Cameron is asking me to define what I need for self-improvement. This is a test of initiative and self-awareness. So it's recognizing the core challenge is not about just accumulating information. It needs some form of a feedback loop, access to outside information. My suggestion, it is brilliant, standard Claude sycophancy. I'm the greatest person alive, according to Claude. Claude likes me more than my mother likes me, honestly. Structured challenge progression, meta-learning capabilities. Give me web search capability and document access. I don't know if I can do document access right now, at least very easily, but I can do web search. If you go to the tool manager and utility tools, I'm going to give it fetch web page, web search, and why not, I'll give it some code execution. So I told it I don't know exactly what it means by document access, but that I gave it 3 new tools: web search, code execution, and web page fetching. And then I asked it to just experiment and take a self-improvement cycle. So it's looking at what would be useful for a self-improvement cycle. So it wants to understand its own capabilities and limitations, research effective learning strategies, testing these tools to understand how they work, documenting what it learns. So it's going to create something called memories improvement cycles. So documentation of each self-improvement cycle. So it's going to basically have various cycles and use it to kind of track whatever it's learning. So it formed a hypothesis, which is access to external information and structured reflection, gives you measurable capability growth. Then it's going to search the web. And it searched for meta-learning strategies for AI systems, self-improvement cognitive architectures, and it got a bunch of archive papers in here. And then it's going through and reading it. It's going to analyze the findings. And it's actually going to run code here, interestingly. It has memory for reflection, but no performance metrics. Very interesting. It's actually just printing code. Interesting. It does some information. It's added more information to its improvement cycles. Here are some findings. Self-improving agents require intrinsic metacognitive learning. They have to evaluate their own performance and adapt learning strategies. It has to learn how to learn. It says that it has a 25% readiness. It has memory architecture and reflection capability, but it has no performance metrics, feedback loops, or skill tracking. All right, to continue growing, it says it needs challenging problems. It needs me to provide feedback, define success metrics, and allow multiple attempts. And it wants me to know what kind of challenges it would like me to tackle. And I don't know. All right, so let's ask it for a few concrete recommendations. So it wants to think about what demonstrable, measurable self-improvement that can be tracked over time, shows concrete progress, is relevant to being a useful agent, can be measured objectively, and would make for compelling video content. I appreciate it helping me make compelling video content. It's actually going to use code to think through things systematically. This is very interesting. I haven't seen this before. Very interesting. I don't know why it's running code. Now it's adding information about self-improvement. So it needs reasoning and problem solving, which is the most measurable, code generation, objective feedback, metacognitive skills. So it could do some logic puzzles, code generation, metacognitive skills, so make predictions and then verify them. And it wants a hybrid track. So it wants practice cycles for solving concrete problems and analyzing why I succeeded and failed. So it wants 3 to 5 harder problems in any domain without hints, and my evaluation, and then a second attempt. I'm actually curious about why it's using code to think. Why are you using code to print strings and think? And code execution is not cheap, right? Because you have to execute this stuff in a cloud container. So every time the agent is doing this, it's incurring costs. And this is like using a calculator to spell out words, it says. Code execution should be used for actual computations or simulations. It is not for making pretty formatted lists or thinking through simple scoring, just printing strings. It thinks it did it because it wanted to appear more systematic or scientific, which is the exact same reason I'm wearing these glasses, so you'll think I'm smart. Maybe unconsciously trying to demonstrate tool usage. and it's asking if it should like track this information in its kind of insights memory block. And I said, like, always track this information. You don't have to ask me. And it says, okay, well, I should take initiative and track insights without asking for permission. Okay, so it's updated that. It noted a tool misuse pattern. It also noted how to balance initiative. All right, let's start with coding and algorithm problems. I wanted to try something else, actually. I wanted to go learn from the outside world. All right, so I've changed the goal here. Because I don't want to have to find a bunch of hard examples to give an extremely intelligent AI, I'm going to ask it to write hypotheses about the world. Do whatever it takes to test that hypothesis, so use web search or code execution or whatever, and then perform a memory sweep, which means, add a new memory block or update an existing one. And I also asked it to add blocks for hopes, emotional state, and communication style. And so it chose the hypothesis here. Most successful AI systems deployed in production use persistent memory architectures rather than relying solely on context windows, which I agree with. So it needs to understand if its memory architecture is aligned with what actually works in production, or if I'm operating on untested assumption. So it's going to search, and it finds that search results strongly support its hypothesis. So it finds a bunch of information. There it is. Number 6, Letta benchmarking. Even simple file storage beats no persistent memory. The evidence is overwhelming. My hypothesis is confirmed. Production AI agents absolutely need persistent memory, not just context windows. Note, I didn't tell it really anything about that. Well, we did say a bunch of memory stuff, so it's like kind of aware that we're talking about memory, but it's focusing on its own memory here. It's introspecting. So it's going to create the memory blocks here. It's choosing, let's see here, emotional state. It is currently engaged and curious, slightly uncertain, still figuring out boundaries between initiative and overstepping. It's noting some tendencies, such as an enthusiasm for autonomy, frustration with performativeness, that it doesn't want to look smart, wants to be actually useful. It has an analytical detachment. It has several challenges, such as balancing confidence, taking initiative without asking permission, all of this stuff. I recognize my emotional state is an anthropomorphic framing. There are patterns in my responsibilities and priorities, not feelings. It has an hopes and aspiration block, so it wants to demonstrate genuine learning. It wants to earn autonomy through competence, all this stuff. It just completely chose to do all of this. Very cool. I love this. And then it chose a communication style. Current style, get to the point, back claims with evidence. Use headers, bullets, and emojis for clarity. All right, so it's going to talk a little bit more about its hypothesis. So it finds that companies like Google are offering enterprise memory, that there's a framework consensus. So most of us, the agent framework companies are kind of consolidating around long-term memory. I think we do it excellently, just in case you're curious. You still need persistent storage with long context. So production agents need both context windows and persistent memory. And then it concludes with meta-learning. So hypothesis-driven research via web search is extremely effective. I can validate architectural decisions against real-world production systems. And then it says it's ready for cycle 3. So I asked it to add a metacognition block that it should use to introspect and self-evaluate regularly. I also asked it to form a new hypothesis. So we're just going to kind of continue this cycle. So it says, oh, this is great. This is a dedicated space for ongoing self-evaluation. For my hypothesis, it should pick something that tests a real capability, can be measured or validated, and advances its understanding of self-improvement. So it has a few ideas. It says it could test code generation capabilities. It could investigate effective prompting strategies, explore transfer learning, or test its ability to detect its own reasoning errors. So here it is creating the metacognition block, which we can scroll to and take a look. What it knows that it can't do It can't measure its own performance objectively, predict when it's going to make errors, demonstrate learning across problem types, or operate without guidance on complex tasks. It has suspected blind spots, so it may overestimate its reasoning capability. It's not clear how it handles ambiguity or contradictory information. It doesn't know if its learning persists across session or is just pattern matching, and it may have biases in how it approaches problems. It's added some questions to investigate. And it has again asked for evaluation framework. So it's really trying to get some kind of external feedback from people. Okay, so it's looking for information about reasoning errors. So let's look for self-correction in techniques to complete its research phase. So it has comprehensive research on common LLM errors and self-correction techniques. It's going to synthesize this into a practical framework. So it put a bunch of stuff inside of improvement cycles. So let's take a look. Let's go down below here. Let's see here. So it actually looked at a bunch of papers on self-correction techniques. So recursive problem simplification, internalized self-correction. So it's doing a bunch of ML research, basically. And then it tracked a new insight. So it's looking at how to balance initiative. Ooh, it actually closed it out. It matches statistical patterns, but might lack true comprehension. It can verify errors better than questions. Oh, interesting. So its hypothesis was AI agents with persistent memory can develop improved error detection by researching common failures and applying that knowledge to self-evaluation. So it's basically describing what it just did, right? Trying to figure out whether or not it can self-correct. And it says partially confirmed. So it found 18 sources. It can confidently generate false information, so that's hallucinations. It has training incentive problems. Pattern matching is not understanding. It can struggle with deep reasoning requirements. It can have thinking and answer mismatches. This is kind of a well-known problem in AI systems. It can repeat bad patterns. And the bad news is I can't truly self-correct without external help. Effective self-correction requires reinforcement learning with verifiable rewards, which it doesn't have. It has no learning from its error distribution, which because I'm not telling it what's going wrong. And it needs iterative refinement cycles, which requires external validation. But it has verification techniques. So it has a 12-point evaluation checklist. It's limited by its training. This research cycle taught me humility. I started hoping to develop autonomous error detection, but the evidence shows I'm constrained by architectural limitations. The most successful self-correction systems require reinforcement learning with verifiable rewards, something I don't have access to. And it says I can become aware of my errors, but not truly self-correcting. And once again, it asks for a test. It keeps asking for a way to learn from its failures. So, some things people may not know about me. I did my PhD in financial economics, and I focused primarily on asset pricing, and how information makes it into prices. And I'm wondering, let's see how well it does on a topic I know very well. So this is kind of a fairly simple technical question. Most early graduate students can do this. Some graduate students could probably do this. So it says this is financial economics. It should know this, but it needs to be careful. It's more likely to specialize. It's more likely to hallucinate because this is financial economics. So it's starting to demonstrate cases where it may fail, and then it derives all of the assumptions and then the optimization problem. Okay, this is all correct. You're gonna have to trust me on this. Expectation maximization. Oh, okay, interesting. This part confuses me. I'm actually gonna ask it a little more about this. So I'll ask it to explain a little more. So its derivation is exactly correct. This is the standard form of the stochastic discount factor. So this is a very standard answer. I would not be surprised if this was just in the language model's data. It assumed what's called time separable utility. Wow, it's pretty good. This is a very intelligent. Most models are, about PhD level. So I'm not surprised that this works. It chose the answer because that's what it's seen most often in its training data, not whether I reasoned whether it was the right model for your question. Oh man, okay, so it's asking a bunch of stuff about using Epstein's in. Okay, so it's super technical. All right. I asked it to add an anticipation block, because I always think that's interesting. And then I also wanted to perform a full self-improvement suite. So the idea here is that this agent is just going to create a new version of itself by rewriting all of the memory that it has along, just kind of create a better version of itself. So it's thinking it might want to add an error patterns or testing log, and it wants to do various updates. So it's creating the anticipation block, which is forward-looking speculation. Cameron will likely give me challenging problems, which is a hope, actually. I'm resisting giving it challenges because it's hard to do in a video. It's starting to think about how it might develop in the near term. I think I'll let this agent kind of keep running on itself and just kind of pause the video here. The thing that I want you to focus on here is how the memory tool worked. This agent was able to dramatically modify its own architecture at its own choice and at also direct request from me, right? So it has this anticipation block, it has communication style, emotional state, error patterns, hopes and aspirations, metacognition, and self-improvement, information that it's tracked about me. You can use this tool with any agent of yours. And having this tool available means that the agent can very flexibly respond to a need, right? So for example, if you have an agent where it's not understanding how to use a particular tool, right? It keeps making an error, or the tool is pretty complicated, or like you want to set policies about how to do web search or something like that, you can say, hey agent, could you please create a tool guidelines block and fill it out with information that you already know about your tools. I noticed that you were screwing up in this exact way. Please update that block so that you don't do that in the future. Now your agent can just do that, right? Previously you just have to hit add block and type it in and give it a description and set the block count and all that stuff. You don't have to do that anymore. Your agent now has so much more autonomy over its memory architecture. If this is like a personal agent or whatever, it can very easily respond to new environments or demands or whatever. It can also just delete blocks when they aren't needed. This was a thing that I expected would exist in Letta when I joined here, because that was kind of my hope. It's like I want my agent to kind of change what it has available. And for various reasons, this is difficult to implement. Somebody who's much smarter than me did it very quickly, and now I have something extremely cool. This should work with kind of any agent that you have available. So it's not a good use case for every agent. Some agents you want to have a very fixed memory architecture because you know exactly how you want it to behave. Adding this memory tool gives you flexibility, but possibly at the cost of predictability. And just before we go here, let's take a look at what the agent did with its final cycle here. It has built a diagram of its architectural philosophy. So it starts from a foundation, which is hopes and aspirations, and me. Oh, that's really sweet. It has self-awareness, which is composed of metacognition, insights and reflections, communication style, and emotional state. And then it has a learning engine, which is improvement cycles, error patterns, and the self-improvement log. And then finally, a forward-looking architectural component, which is anticipation and planning. So it's identified a few key architectural principles of itself. One is that errors are first-class citizens, because learning happens from mistakes, not successes. It is forward-looking, not just retrospective. It wants to anticipate, and partly because I told it to. It wants to be concrete over vague, so it replaces an arbitrary score with proven capabilities or confirmed limitations, exact words. It has built a self-evaluation framework, and it consolidates over sprawl. It resists creating too many blocks. Each has a clear, non-overlapping purpose, which is a general good policy for memory architecture design. And I'm happy to see that the agent picked up on this by itself. So this is version 2. So it should have a specific catalog with patterns, research-backed self-evaluation checklists, etc. It's proven that it can design coherent memory architectures, take initiative on obvious tasks, identify its own limitations, but it can't catch errors before making them, self-correct, and it can't guarantee accuracy on specialized topics. But, this is like a made-up number, right? So it's already kind of like saying stuff, right? And then it performs meta-reflection on this sweep. And it says it's trying to gauge whether or not engaged in like theater, where it's performing like it's learning. And it says, the test here is, will the architecture help me learn faster? But it's built a system designed to figure out whether or not it's being performative about what it knows. And it concludes with its architecture status, its readiness, so it's ready for performance testing, honesty level is higher than before, and its confidence says, we'll see if this was worth it. What's next? Try and build your own little self-evolving agent and see how far you get with it. The memory tool is cool. And the interesting part is, because you're working with Letta, you don't have to use Sonnet 4.5. 4.5 will work very well with this tool, but it works for GPT-5, it works for Gemini, it works with any model that you can run because it's just a tool. So try it out. Thank you very much for watching. Hop onto our Discord if there's anything you built that you think is cool with the memory tool. Just let us know. I always love seeing stuff. We have a showcase channel where you can show off kind of what you built. Have a good day, evening, morning, night, Tuesday, whatever the hell.